Hello, welcome to Business Statistics. In this lecture, I will discuss data classifications and levels of measurements. The topics I will cover in this lecture are data classifications, levels of measurements, time series data, cross-sectional data. Data classification, there are two types of data, qualitative data and quantitative data. Qualitative data is data that can change in kind but not in degree. They are often represented by labels, descriptions, attributes, and qualities, and they do not have naturally occurring numerical values. Examples would be male, female, occupation, which is doctor, lawyer, professor, eye color, which is brown, blue, and green. So if you see qualitative data, they tell about the qualities or attributes or descriptions. Here they don't have naturally occurring numerical values. However, we can give them numerical values artificially. For example, we can say male I can give a number 1 and female I can give number 2, and when someone claims number 2, it means they are referring to female, and if someone says 1, they are referring to male. Similarly, we can give for doctor number 1, for a lawyer number 2, and for professor number 3. If someone says number 3, they are referring to professor. If someone says 2, they are referring to lawyer, and if someone says 1, they are referring to doctor. Quantitative data, these are like as the name specifies, they are numerical in value. They have magnitude and they can be ranked, and they naturally take numerical values. Examples would be height. So we measure height in numerical values, which is 5'8". Weight, again 180 pounds, it takes a numerical value. Age 35, it takes a numerical value. We can rank them. So suppose salary, if we have a person 1 earning 200k and person 2 earning 100k, we can rank them and say that person 1 who is earning 200k is richer than person 2 who is earning 100k. Quantitative data can be of two types, discrete and continuous. Discrete variables are countable numbers. We can count them and they take whole numbers. For example, countable numbers are 1, 2, 3, so on. So these are whole numbers. An example of discrete variable would be a number of students in a class. So we can count each of the students. Suppose we have 40 students, it's a whole number. So that's a discrete. The other example can be number of cars in parking. So again, cars are whole numbers, we can count them. So if we have 100 cars, it's a discrete variable. Continuous numbers, they can take any value within a certain interval. So they can be fractions and decimals. For example, 0.5, 1.8, 2.6, all these are decimal numbers. 2.3. So these are continuous numbers. An example for continuous number would be height. So height, if you see, we measure 5'7", 5'9", these are decimals. So these are continuous numbers. Weight can be continuous number. So a weight of a person is 180.4 pounds or 200.3 pounds. This is a continuous variable. Levels of measurement, it tells about quality of data. For qualitative data, there are two levels of measurements. One is nominal and the other is ordinal. Nominal, it is just name or identifiers and we cannot rank them. That's why it's called unranked categorization. Examples would be gender, car color. So if you see, we are just describing them. So gender, male and female. So we cannot rank them. It's no one is male or female, no one is superior to one another. Similarly, car color, black, white. So we are just describing it. We can't rank them. So that is nominal. For ordinal, as the name specifies, we can order them or rank them. So it has all the characteristics of nominal and we can rank it relative to one another. An example would be, mostly we do surveys. Those are ordinal data because in this example risk level, they ask you to rate low risk, moderate risk and high risk. So we can rank them. We can give scores like 1, 2, 3 also. I wanted to discuss again the qualitative data can artificially take numerical values. However, addition, subtraction, multiplication, division are meaningless. I can explain this with the example. Suppose we have male, I can code male as 1 and female as 2. So if I say 2, it means I'm referring to female, and if I say 1, I'm referring to male. However, I cannot add them. I cannot say 1 male plus 2 females is 3 males, or 3 females. So this rule doesn't apply, so it's a wrong. We cannot add male with female. So addition, subtraction, multiplication and divisions are meaningless in qualitative data. Quantitative data, we have two levels of measurement. One is interval and the other one is ratio. So interval, it has all the characteristics of ordinal data because it's a quantitative data. It takes a numerical value. However, in this, 0 is arbitrary or meaningless. This is meaningless. This is not meaningful or meaningless. Interval comparison is meaningful. So interval means difference between two values. Ratio comparison is meaningless. So we will discuss the interval by using these examples. One is temperature and the other would be IQ test. So the first thing is 0 is meaningless. So when we said 0 degree Fahrenheit, that does not necessarily mean no temperature. So 0 temperature is like we say there is temperature and it's cold. So this is 0 is meaningless. And then this is the ratio test, which is 80 degree Fahrenheit divided by 40 is 2. So we cannot say 80 degree Fahrenheit is twice as warm as 40 degree Fahrenheit. This is meaningless. However, we can say 80 degree Fahrenheit is 40 degree warmer than 40 degrees. So I can do 80 minus 40 and say 80 degrees is 40 degree warmer than 40 degree Fahrenheit. So this is interval test where I can take the difference. So this is meaningful. Another example I can give is IQ test. So this is intelligence test. So if we have 0 IQ score, it doesn't mean we don't have intelligence. We have some intelligence. So 0 score, if we score 0 in IQ test, it is meaning we cannot say we don't have any intelligence, so it is meaningless. If someone scores 100 in IQ test and the other person scores 50, we cannot say, we cannot do 100 divided by 50 and say person 1 is twice as smart as person 2. So this is not a meaningful conclusion. The third one is I can say 100 minus 50, which is 50. I can say person 1 scored 50 more than person 2. So it becomes meaningful. It is meaningful. So ratio test, in this we have all the characteristics of interval data. Measurements on a numerical are on a numerical scale because it's a quantitative data, and 0 is meaningful here. Both interval and ratio tests are meaningful. So examples would be money, earnings, height, weight, defects in a production process. Suppose John earns 120k and Paul earns 40k. We can say John earns, so this is interval test. So what we are doing is we are saying 120k minus 40k, 80k, and we are saying John earns 80k more than Paul. And then we have this is ratio test. So what we are doing is 120k divided by 40k is 3. So we can say John is 3 times richer than Paul. In ratio test, 0 means no money, so 0 makes sense. So if we say 0 money, that means we don't have any money. So here is levels of measurements summary chart, and we have data. These are data classifications. Qualitative data is, it can change in kind. Quantitative data, it can change in magnitude. So we have discrete, which is discrete variable under quantitative data, which is countable, and then continuous is it takes decimals. These are levels of measurements. So nominal, it is name or identifier. So they just describe, or they are just attributes. So data can only be classified. Ordinal, we can rank them or order them, so they can be ranked. Interval, So meaningful difference, which is interval. 0 is meaningless, so 0 becomes meaningless. 0 does not necessarily mean absence. Ratio is meaningless, so we can't do ratio test. Under ratio, 0 is meaningful and ratio is meaningful. So some of the examples, these are examples. So shirt jersey numbers of players, they just represent the numbers. There is nothing more than that. We cannot rank them or we cannot add them, subtract them. So make of cars, they just like Ford, Toyota, they just tell about the car. Zip code, again they tell about the geographical area. They don't tell anything else. For ordinal data, survey, so your customer care surveys which ask them to rank, those are ordinal data. Pain level rating when we go to a hospital, that's ordinal data. Interval, for temperature, 0 doesn't make sense. 0 temperature doesn't necessarily mean no temperature. Again, dress size, 0 size doesn't mean there is no dress size. Hours on clock, 0 time doesn't necessarily mean it's the time period is 0. So that's interval. Ratio, distance, 0 distance means you didn't travel. 0 weight means there is no weight. Number of defects means there is no defect. So these are some of the examples of different levels of measurement. So time series data, measurements taken from a process over equally spaced time. Example would be measuring the quality of a product coming out of a production process every 5 hours. So we are equally spacing the time. That's called time series data. There are two types of time series data. One is stationary process, which varies over central value and has approximately same variation across the series. So the process is in control. So if we have upper limit, and so this is upper limit, so I will say UL, and this is lower limit, and this is the central value, which is mean. So each hour we will take our outputs of a production process, and they all align around the mean or central value. So in this case, the process is in control. Non-stationary process, the time series process shows a trend. Trend can be positive, which is increasing, or negative, which is decreasing over time, and this is process is out of control. So if we are tracking the process, again this is upper limit, this is lower limit, and here we have a mean. In this, the process is not stationary, they show a trend. So this is time period 1, time period 2, time period 3, 4. So as we progress, the trend keeps on increasing. So it shows an increasing trend, and as such the process is going out of control. So that is time series non-stationary process in a time series. So here is another example. So here MSW means municipal solid waste. This is US EPA data for municipal solid waste generation rate from 1960 to 2011 in US. And if you see this trend, it's in 1960 88.1 million tons of waste is generated, and in uh, uh, 2011 250 tons, and if you see clearly the trend is increasing. Similarly, if we see pounds per person per day, the trend shows it's also increasing. So this is non-stationary process. So finally, I will discuss cross-sectional data. So these are measurements created approximately at the same time period of time. So if you see in 2016, this survey is conducted on which countries generate most electronic data and electronic waste. If you see, China generates most, United States. So the survey is conducted in 2016. So mostly the data gathering occurs at the same period of time across different geographical areas. So that's the main concept of cross-sectional data, which is the data is taken around the same period of time. This concludes our lecture on data classification and levels of measurements. Thank you.